any loss function. For simplicity, the diagram is shown like this. Normally ऐसा नहीं भी हो सकता. So in this case, this is a cross entropy loss function, and there are two x's that are going out. One is a W, other is a B. Stands for weight and bias, right? I skipped bias yesterday intentionally just to keep things simple, but it is also a parameter. So simply you had an input layer, right? Input layer, some neurons here, then you had say next layer. So these are connected. We discussed it yesterday in the yesterday's class. These are connected. These are all weights. So this W is actually the cumulative weight of say this is weight 1, weight 2, weight 3, weight 4. So this all is represented by this complete W. So it means we are trying to find appropriate values for these weights. Together with there is another input that goes into neurons, right? That is bias. It also has weights, say B1, right? B2 for all the neurons. So that's why the name is B, a common name for this one. So since the loss function has to be minimum, so अगर मैं इस diagram को देखूं, so its value is minimum at this point, right? Which is being circled by me at this stage. So the best values will be the values which I get by drawing perpendiculars from this point on W axis, right? This one, right? Or on B axis, that means this one. So these are the values which are best values. Means for these values, the value of loss function is minimum, right? All other values, they may not be minimum. Say if I just my loss function is ending up at these points, the values are not going to be minimum. So I'm going to get and say suboptimal values for W and B. So the whole theory is finding an appropriate values for W and B for which your loss function is minimum, right? So we must be clear about this thing, right? And how does it all work? It all works by, say, this is the same curve, right? It's in a 2D sort of shape. So what we basically do, we start with a random weight, right? Say this is the weight we start. So for this weight, we'll be having some loss function. Say the value of the loss function is this one. Right? Let me change color for this to highlight. So the value of loss function at the start is say this one, pointed by this one, right? Then we make changes to the weight. So we try to decrease weight or try to increase weight depending upon to what side of the function we are, right? If we are on to this side, if we are on to this right side of the function. So the minimal value we know is lying here, right? Minimal value is lying here. So our the algorithm job is to come to the left like this, like this, like this, like this, like this, and reach somewhere here, right? So the theory is that we make weight adjustment. जो weight adjustment करते हो, when we say that we are changing weights or depending upon the loss, right? You can say the pictorial representation of this is as you see on the slide. It means you are trying to reach at this particular point. And similarly, if you start from this particular point, so you end up here, the starting value, and your job is to move to the right hand. And the formula that is being used is this one, W minus alpha dj. That means the rate of change of W, where W is again a parameter with respect to dW. So it is a derivative, right? So again, a bit of mathematics, derivative. अगर मैं यहाँ पे होऊंगा, see, observe this. अगर मैं यहाँ पे होऊंगा, my loss function is increasing upwards, तो मेरा derivative ऊपर आएगा, right? So it means the value of this G or the gradient will be positive here. So the value will be positive here. It means from if I just substitute this into my this formula, अगर मैं इसको यहाँ पे substitute करता हूँ, so what is the effect? W new is equal to W old minus some positive value. So it means इसका effect क्या होने वाला है? The effect of this is that I'll be reducing to whatever value of W was initially to some less value. तो in a way कि अगर मैंने यहाँ से start किया था W, so my new W will be somewhere here, right? I'll again calculate this point, and with the hope that if I do it a number of times, I'll end up at the minimum point. On the contrary, if I'm to the left of this figure, if I'm here on to the left, right? यहाँ पे मेरा gradient की value negative आएगी because it's increasing like this. It's a monotonically increasing function, right? So my value of the gradient will be negative here. So if I substitute into the formula, so the effect will be W is equal to W plus. So minus minus gets plus. So I'll be adding up to the previous value of W. So its inherited effect is that I'll reach here. After first iteration, then after second iteration, I may reach here. Third iteration may reach here, and so on, so on, so on. Right. So this is the whole theory of optimizations, right? Means you, of course, there's lots of math derivatives and all. The very abstract level, this is the theory, and I hope you get into this aspect, right? There is an important thing again. You must remember that is alpha here. Alpha is what? Alpha is my learning rate, so it's the rate, or more appropriately, it's the learning rate. It means आप कितनी जल्दी weights को update करना चाहते हो, to what factor you want to weight. If it is high, if alpha is high, it means you will be updating it very quickly. आप बहुत ज़्यादा quickly इसको update करोगे. If alpha is low, it means it will be leading to slow updation. तो आपका जो ये steps हैं, the steps will be smaller, 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 right? So this is the role of alpha, learning rate here. So I hope this thing gets into mind. If it is fine, so I just thank you. The first optimization principle, right? The first optimization principle is learning rate decay. Please see this. What is this says? It says my learning rate, right? If I see this curve or the loss curves, right? क्या हो रहा है यहाँ पे? If I just put it here, the value of the gradient is very big, and it's big here, right? It's big here, but as you grow, as you go to the near of this, right? यहाँ पे gradient की value बड़ी थोड़ी हो रही है. What does that mean? What people thought about, if we are at this particular point, right? If we are somewhere here, we shall keep alpha high. Why? Because there is no harm in taking bigger steps. तो मैं अगर यहाँ से start करूँ, in a single step I may reach here, and then in the next step I may reach here, and next I may reach here, I may reach here, I may reach here. But as I gradually go along, they say the plateau, right, or somewhere at the bottom, जहाँ पे मेरी slope flat हो रही है उसकी curve की, then I need to drop alpha. और आई नीड टू ड्रॉप इट, सो आई नीड टू मेक अल्फा लो. तो मेरे को अल्फा लो करना चाहिए, बिकॉज अगर मैंने अल्फा की वैल्यू ज़्यादा रखी तो हो सकता है कि इफ़ आई जस्ट आई वाज हियर एट से स्टेप नंबर 10 at 11th, I may go here, right? And once I reach here, I may go back again here into negative power. So I may oscillate between the minimum. So it is quite possible I may not be able to reach an optimal value here. So what people thought about is that to start with, जब आप training start करते हो, keep alpha high. You keep alpha high means you may take bigger strides. But as you go along, जैसे जैसे आपकी training बढ़ रही है, you please decrease the value of alpha. So that's why the name is learning weight decay, or not weight, so it's a typo, learning rate decay. Please see this, learning rate decay. Please make the correction, it's learning rate decay. Fine. So it has proven to be very helpful in minimizing the, you can say, differences between the training loss and validation loss, and also speeding up the training process, right? Because in a single step, मतलब जो आपने यहाँ से start किया, you want to reach here, say you're taking 10k steps. If you keep static learning rate, right? It may be possible that you're able to reach in 7k steps. You are reduced by a factor of say 3,000 steps, right? So this is the whole theory about learning rate decay. Please, I'll show you the implementation of this, how this could be done, right? But before this, let me discuss further. So when you train, right? When you train your network, it's very you can say convenient, or it makes sense to look at two different things. What are those things? You please look at your training set error, and you look at your dev set error. Dev set error means your validation set error, right? Of course, there's a testing set error. I'll come back to again these points, but validation set error also gives you certain points, right? To the top of the slide, you are seeing three pictures or three graphs, right? Where red and crosses and circles, they tell you different data items into my data set, right? The left one में there is a straight line that has been drawn. It means this is my classifier. My classifier is actually dividing into my two data set into two different categories, right? If I just look at this, this is not good. Well, this is not a good classifier. Why? Because there are so many samples that are misclassified, right? There's a circle that is present on to all in between all your crosses, right? There are so many circles which are misclassified, so many circles which are misclassified, right? So if this is the case, right, it means this is actually a training error. So this is a training error. It means मेरी जो ट्रेनिंग एक्यूरेसी होगी वही ज़्यादा अच्छी नहीं है. My algorithm is making you can say errors on the training data itself. Fine. And if you look at this one, right, say the right one, the right one is actually, if I just look at this all, so the training error or train error is zero, right? It's almost zero. But when this is, there's a high chance that when such an algorithm is being tested onto, say, the testing data or validation data, so it will lead to high validation errors, high validation errors. Right? So if this is the case, and we say that it has high variance.
सर हाई वैलिडेशन एरर्स क्यों आएगा जब हमारा ट्रेनिंग एरर ही जीरो आ गया तो?
Sir, validation actually the reason is that training samples and my validation samples are different. So it's something like this कि आप एग्ज़ाम ले रहे हो बच्चे का, आपने जो तो क्वेश्चंस बच्चे ने आपने क्लास में करवाए थे, राइट, वो तो उसने बड़े अच्छे से आंसर कर दिए. But if you manipulate your statements in a way, right, the child is not able to perform in a good sense. अच्छा लगा लिया. So we normally say that neural network has only remembered the training instances. उसने training instances को तो याद कर लिया एक तरह से, but it's not able to generalize. Right? So,
ओके सर.
neural network is the one which is able to generalize onto the unseen data, because in real life, जब हम models को deploy करते हो, हमें unseen data की performance लेनी है. So in this case, we say that the validation error will be high, and it says it's a high variance. So two terms, bias is related to training error, and variance is related to your testing error or validation error. Right? So what is the target? Target is that bias algorithm as well as variance algorithm. This is probably target for any training algorithm. Right? And if you see the center curve, अगर मैं center curve को ध्यान से देखूं, it's perfectly okay. It's just right curve. क्यों? Because there are some samples which are misclassified. See, this one is misclassified. This one is also misclassified. But it's okay. We don't want a student to be scoring always 100%. Even if a student is scoring say 99%, we always say that this is also good, right? No, but इसमें ये है हमारे पास, it has been again observed that this has a high chance of performing better onto unseen data. मतलब एक ऐसा student है जिसने concept सीख लिए, and it will be able to generalize things into a normal manner. Right? So these three diagrams, these are the golden diagrams for any data scientist or any machine learning, bias versus variance, right? Okay, and if this is the case, it means if it is a high variance, then we say that this is an overfit, right? Overfit means training set is minimum, but it's not performing good on validation set, right? So the one on the right is overfit of data, and the one on the left is underfit. So it's underfit. जो आप left में देख रहे हो, this is an underfit. Means उसकी performance अभी जो questions हम उसको करवा रहे हैं वहाँ पे भी अच्छी नहीं है. So we look at both. आपके लिए दोनों important है, depth set error as well as train set error, to understand whether the network is underfit or whether the network is overfit, right? So on the next slide, I think I had no. Okay, I have missed that slide. So I'll tell you the general rules की करना क्या है आपने उस केस में. So first understand there is more intuition that is at the bottom of slide. So insert of errors. आप numbers की form में इसको कैसे देख रहे हो? Say if my training set error is 1%, right, and if dev set error or validation set error is 11%, so it means it's a high variance and it's an overfit. So look at your figures and try to figure out कि हो क्या रहा है इस केस में, right? And please make sure this one, right, this assumes कि in case कि मेरे पास क्या है, my say human error again, this is all relevant. Human error is almost 0%. Well, these numbers make sense only if we say that human is able to perform with a 0% errors, right? Only then these numbers will make sense. But for a problem जिसमें human error is ज़्यादा है, say the human error is say 20%, right? For 20%, even all of them will may make sense. So ये सारे numbers हैं, they are in a form कि if I assume that human is almost perfect, right? Next is say 15% for training set error and 16% for dev set error. So training set is quite high if you look at this 15%. And if I just correlate it with the human error, it's quite high. So we say that it's a high bias problem and it's an underfit. If it is both 15 and 30, it means both are again high. Your bias is also high, your variance is also high. It's both an underfit and overfit problem. So in this case, this is both low. So this is almost fine. This is perfect sort of thing that we have done. This is perfect. But I again stress it out. This is again with relevance to figures. जो figures आप देख रहे हो slides में with relevance to human errors is almost zero. उस case में है. If my human error is say 15% or 20%, even this is also good. Right? This is also good. The next one. क्वेश्चन इज अब करना क्या है. सपोज ऐसी प्रॉब्लम आए आपके केस में व्हेन इट इज एन अंडरफिट, से अंडरफिट, it means your neural network is weak, so you had a weak neural network. What to do? Increase the number of layers. आप number of layers को increase करो, right? Number of neurons को increase करो. Look for certain other regular optimization activation functions. So you play with your network architecture if this is the case, right? When it is an overfit, supposedly it is an overfit, it means आपके neural network में इतनी power है कि वो training data को उसने handle कर लिया. Now you just need to minimize errors onto your validation error or onto your testing data. Right? तो overfit के लिए क्या करना है? It means you must get some data, right? Get some more data. So please pass on to the neural network more data. आप data को और ज़्यादा pass करो neural network को, it will be better. And you add some regularizers, right? You add some regularizers. Regularizer means L2 regularizers. There is, I just mentioned you just in the previous slide, weight decay, learning rate decay. There are plenty of things that are coming up in the lecture also. So then you play with those things and hopefully your dev set error will also be minimal, right? For underfit, the golden rule is your neural network is weak, try to increase the strength of neural network. Of course, data is may help but may not be of more help to you. So you first play down with the neural network architecture. Fine. With this in mind.
Right, sir. Right.
Right. So let's proceed further. What do you have to do with data? So data is maybe available, maybe not available to you. So depending upon what type of task you are solving. But please divide your data into three parts, right? Normally we say that training and test, but it's always advisable to divide into train, test and validate. Even in yesterday's lecture आप लोगों ने देखा होगा जब मैंने ट्रेनिंग आपको दिखाई थी तो उसमें भी एक 3 तरह से डिवाइड किया था, ट्रेनिंग, टेस्ट एंड वैलिडेट, right? So there may be figures like this, as you pick on 70% here, 30% here, and from this 70% you could borrow say 10% and divide it accordingly, 70-30 from this 10, or depending upon this is a task that by looking at how big your data is, what is the quantity of your data, आप उस तरह से ratios को divide कर सकते हो. There are no golden rules, no principles that will guide you, right? You have to look at your data and figure out what is the optimal breakup. And in fact, in neural network, there are no golden rules. I hardly had seen any golden rules for neural networks, right? The theory is quite open. You play around with different things and find out what works for you, what may not work for you, and what is working for, say, an individual A may not work the same for individual B for a different set of problems, right? So this is the beauty, right? For larger data, so your ratios may be like this. So it may be say 60, 30, and 10. So for larger data, so even 60% of the training samples make sense. Then you may reserve 20 for this one. For bigger data, even 95% of the data may be sufficient for training. Uh, this is important. We shall make sure that dev and test sets come from the same distribution. It means you please select randomly. So randomness is, you can say, the most important thing that you must consider. For example, I had so many samples. Please don't be specific. I'll pick say 100 samples for say testing first, the next 100 for validation, the rest for training. अगर इस तरह से है then it may be problem. First step is you just shuffle your data. You please shuffle your data. It means आप shuffle कर लो जैसे cards को shuffle कर रहे हो. So means वो कोई भी कहीं भी जा सकता है. You give equal chances of going taking any sample into even the training set, test set or validation set. These small things, they actually help, right? I have seen it personally. They help.
सफल कैसे कर सकते हैं सर? सफल किस प्रेशर से करेंगे, कैसे करेंगे?
There are actually functions. I think in TensorFlow itself, tf.shuffle, if I think it's a function. And sir, mind you, अब ये सारा काम ना बड़ा पहले मुश्किल था. Nowadays, जब भी आप training pass करते हो, the libraries are so good, right? You just have to call a function and they do it automatically.
Okay.
Right, so you don't have to worry that much. But you're teaching a student, you must tell them that it's quite important task to shuffle.
Okay. Thank you.
File से data read करते हो खुद ब खुद ना, then you need to shuffle that.
Okay.
So first task is you must normalize your inputs. I think it's the very basic task जो हम सभी करते हैं, right? मतलब जैसे हम इसको, if you're saying कि भाई मेरे scattered हैं, distributions are scattered, the values of x2 are this much. So यहाँ the range of values of x1, x2 are this one, whereas x2 goes like this. It's a big x1, right? So it's not good thing. Why it's not a good thing, I'll come back to the next slide. But what we do, right, we find the mean and subtract the mean, right? We find the mean and subtract it from the whole data just to bring it to one centric point. So then once this is done, you normalize your variance also. It's all scattered. Even if you subtract the mean, it's scattered again. We don't want to do that because you want both your features to be across in the same range. So what do? You normalize the variance also, and this is almost a good thing, right? अभी करते क्यों हैं? Please understand this slide, right? Why do we normalize inputs? These are fairly simple things, but we don't observe. To the left of your figure, you are seeing a diagram of a loss function. So ये जो आप देख रहे हो in colors, this is actually my loss function, जिसको मैंने minimize करना है, right? This is another way of seeing the loss function. मतलब इसमें 3D diagram की तरफ है, इसमें concentric circles हैं again, but the same things are there, loss function. So if I'm not normalizing, see my W1, the weight matrix 1, इसमें x1 की values हो सकती है 1 to 1000 हो, और x2 की values है ये 0 to 1 हो. So actually learning algorithm ने क्या करना है? It has to find an optimal value for W1 and W2. Where W1 and W2, they will be affected by the values x1 and x2. तो मेरी एक इनपुट तो रेंज कर रही है 1 to 1000 में. तो होता क्या था, अगर आप इसको थोड़ा सा बैक जाओ, W1 into x1 करोगे आप, right? So the effect of this will be very large as compared to the effect of these values. It's very small, tiny, right? So जब आप इसकी minimization में करोगे, the effect is that you are trying to find a minimum value from these small points. मतलब इतनी range रहेगी आपके पास जहाँ से आपके ने minimum ढूंढना है for an unnormalized data. But if I just normalize it, so the value or the range of the values gets big because they are now equal. The effect of W1 and W2 is now almost equal, right? So in a way, you are giving a better chance for your learning algorithm to find an appropriate values for the weights W1 and W2, right? This is the whole theory. So simple. So that's why we always normalize our inputs onto the same range, 0 to 1, right? Floating numbers. And if you again recall, we have done it in yesterday's training algorithm also. We have divided our inputs by 255, divided by 255. ये मैंने भी किया था. Almost all the experts that might be coming, they will be doing it by normalizing. Right? Okay, further. So this is the first task. Then second task, second जो काम कर सकते हो आप अपने networks को improve करने के लिए, data augmentation. What is data augmentation? Data augmentation is that you sometimes you may not have much data. आपके पास data नहीं है, data आप capture नहीं कर सकते, data available नहीं है. What can be done? Right? People have found solution to this one. By virtue of the things that are known as data augmentation. What is that? आपके पास जो data है आप उसी को increase कर सकते हो, right? For example, you are seeing 3 pictures of the cats. Say this is the original picture. By playing around with some tricks, right? आपने उसको flip कर दिया, आपने उसको थोड़ा सा rotate कर दिया by some degrees of the object. आपने उसको color से grayscale कर दिया by playing these tricks. What you could do, right? You could augment or you could create more images of the same data, right? This thing is known as data augmentation, right? And जो आप नीचे देखो in terms of character, say this is also 4, and you will agree this is also 4, this is also 4, this is also 4. There is some sort of sheer transformation that has been applied to these images, right? So this is again a trick to increase the number of samples into your data in case you're found short of your data, like data augmentation. Mind you, जितना मुश्किल लग रहा है करने का उतना मुश्किल नहीं है, because again libraries come up with or Keras comes up with this image data generator. So you use that, you import this package. So call this with whatever things you need, rotation range 40, shift range 2, right? There are so many parameters to play with, and you will generate number of samples. तो आप जितने samples चाहते हो उतने generate कर लो. So it will give you more data, and अगर आपने save नहीं करना data को, then you could pass it during the training. आप during training भी उसको samples को बढ़ा सकते हो. There are two ways. आप during training pass कर दो, और आप उनको save कर लो for further references. This was slide I was looking for. If it is high bias, the bias ज़्यादा है, variance ज़्यादा है. So if it is high bias, you please make bigger networks. I just told you so this slide is actually misplaced. I'll shift this to that particular point. Bigger network, more layers, add more layers, train longer, try different architecture. So अगर आपके पास training error है तो आप ये काम करो. This is the suggestion, right? And this has proven to be effective. Target is you first get rid of bias. So पहला काम आपका ये होना चाहिए कि training error जो है आपका train error shall be almost 0, right? Only then you proceed to remove your variances, right? Or not 0, almost 0, equivalent to 0. If it is high variance, right? If it's a problem for your test validation set, then you need to get more data, try regularizations, and if all doesn't work, then only you shift to neural network architectures. So you may play down with the architecture at the bottom, but the first thing that you must try is more data and more regularizers. Right? Try to remember, please, again.
Regularization means?
I'll come back to this, sir. I'm just starting with the regularization. I'll just give you what is that regularization. So, very important concepts again. अब ये सारी चीज़ें जब आप curves plot करते हो, if you could again recall from yesterday discussion, मैंने ये दिखाई थी curves आपको कि आप इस तरह से plot कर सकते हो. इसमें आपके पास loss है. So we had loss, दो curves थी हमारे पास. एक accuracy की curve थी, एक loss की curve थी. So curve of importance is not accuracy, sir. Remember, curve of importance is your loss curve. So accuracy की curve ऐसे करके जा रही थी. Right, training error and say validation like this. So this was the accuracy curve, the top पे है. Loss curve is important. So इसमें दो तरह के losses हो गए, training data loss and validation loss. See, you please observe the gap. This is high. If it is high, it means, and you please look at your excess. Excess में क्या है? If it is almost 0, so it means अगर 0 है तो मेरा training error तो 0 हो गया. Right, but my validation error is high, right? This will indicate to you कि भाई अब गड़बड़ है मेरे algorithm में validation errors है. I need to do something, right? So it's not a generalized curve. मेरी अगर generalized curve रहती, generalized curve means a student who has learned the concept beautifully and is able to generalize different concepts. तो वो curve मेरी इस तरह से रहती. It could have been very much over this one. almost over this one. तो इस तरह से curve रहती. Let me draw it into a different color for. Yeah. So मेरी जो I'm drawing the expected curve. So मेरी curve इस तरह से रहती with almost overlapping. So if it is like this, validation, right? It means it's perfect. Means it's almost perfect curve. ऐसे चाहते हैं हम curve. But if it is a difference, दोनों में difference लग रहा है आपको, it means something is wrong. You may do something. Then again, the choice is yours. If you want to do it, you must do it. Otherwise, ट्रेनिंग सेट में आप फिर भी रिजल्ट्स देके पेपर पब्लिश कर सकते हो. ओके, फर्दर अब करना क्या है? कम regularization. What are regularization? Regularization क्या है? They help to prevent overfitting. तो हमने देख लिया what is actually overfitting. Now they help to prevent overfitting. And what has been observed? कि neural networks that is overfitted usually has a weight value that are large in magnitude. मतलब उस केस में वेट की जो वैल्यूज होंगी बहुत ज़्यादा होंगी. मतलब जो वेट अपडेट कर रहे हो आप ड्यूरिंग द इंटरवल्स ऑफ टाइम, वो वैल्यूज बहुत ज़्यादा होंगी. से मे बी अगेन दीज आर सम नंबर्स डिपेंडिंग ऑन प्रॉब्लम टू प्रॉब्लम, राइट. मतलब बहुत ज़्यादा मैग्नीट्यूड होगा, ऑल्दो मे बी नेगेटिव मे बी इन पॉजिटिव. सो विच इज़ नॉट आइडियल. अगर स्मॉल हो तो अच्छा है, बिकॉज देन द एरर्स विल बी मिनिमम. So what people thought about, why can't we in a way keep weights small? तो weights को कैसे small किया जाए? तो again there are different things people come up with. Regularizations, तो उसके लिए क्या है? There is an L2 regularization, of course there is an L1 regularization also, right? L2 regularization is given by this vector. What we do, we add a penalty vector. Penalty means if this value goes high, we want to keep it minimum, so please understand, and this is my error function. I want to minimize this. मैंने इसको minimize करना है, and this factor will govern. Now this is my penalty term. अगर ये बहुत ज़्यादा हाई है तो मिनिमाइजेशन के लिए क्या करना पड़ेगा? इसको मिनिमाइज करने के लिए हमें इसको कम करना पड़ेगा, so that this is minimum. So अगर ये कम है, then I may increase this to certain values, right? So that I could again keep the weights into some reasonable numbers, right? So we add a penalty term just to keep in the values of weights in check, right? And there's an important point you must observe here. So this weight penalty is independent of data. There is no role of data here, please. We are actually playing with only the weights just to keep them in check. So it has been observed कि अगर weights को हम in check रखेंगे, right, it will prevent overfitting. तो overfitting को prevent करेगा, right? So this is again there's lots of maths and all, derivation and all, and if somebody is interested in derivation, you can go to Andrew Ng's lecture. तो वो सारी derivations भी करके दिखाता है, but वो ज़्यादा मतलब उन लोगों के लिए that they want to work into regularization only. Normally लोग क्या करते हैं, L2 norm को use कर लेते हैं concepts में. Fine. So please stick to this L2 norm, right? So आपको ये parameter की value देनी है depending upon what sort of weights you are having, and the job is done for you, right? So this is what I was talking about, the whole theory, lambda, right? ये square में क्यों है? Because it's L2 norm. It's equivalent to W1 square plus W2 square plus Wn square, the norm of that. L1 norm क्या होगी? L1 norm is W1 plus W2 plus W3, the mod of that. So that is an L1 norm. So the difference is obvious, because since I assume that all of you have studied L1 norm and L2 norm, so it's analogous. L2 norm is squares, right? L1 norm is just the mod of that, right? Calculations also here you mistake. All the weights are fine except this one. Please see this one. So it means जो problem हो रही है मेरे इस weight से हो रही है, and because it is contributing 25, where the rest of the weights are very small. So, and L2 norm क्यों use करते हैं? Because अगर ये सारे ऐसे ही रहते, अगर मैं इनको square नहीं करता तो क्या होना था? तो this could have been 0.2, this could have been 0.5, and this could have been 5. Means जो relative percentage of contribution है वो highlight ना होता. Fine, so that's why we square them. So that's the reason of squaring all the functions. And L2 norm is seen to be performing better than L1 norm, right? Again, but No golden rules. You please try and then find out what works for you. Same theory. I'll share the slides. You people can read. And mind you, just to high lambda means the value of lambda, the weight frequency will be this. It's a shrinkage, right? आपने weights को shrink कर दिया. Because lambda is high, the weights will be small. Minimization problem. दोनों को product को आपने minimize करना है. If lambda is low, the weights has to be scattered, so they are scattered everywhere. Minimization problem. Okay, just a simple pause, right? I'll like to share you. There's a course of Google also. I'll share the link in the chat. आप जहाँ पे I just forget it to share yesterday. Sorry, अभी याद आ गया. Let me. Here you had what they had given you. They have given you this architecture, right? In which you could add some features x1, x2, right? You could add neurons like this one. I'm adding, right? You could add hidden layers. Say you could add a hidden layer. It means आप on the go अपने architectures को बना सकते हो और उसको ट्रेन कर सकते हो, राइट? आप यहाँ से डेटा सेलेक्ट कर सकते हो व्हाट डेटा सेट यू वांट टू हैव. दिस वन ट्रेनिंग डेटा परसेंटेज आप यहाँ से सेट कर सकते हो, राइट? अगर सैम्पल्स में नॉइज डालनी है आप नॉइज डाल लो अपने सैम्पल्स में. बैच साइज, आई जस्ट कम बैक टू व्हाट एक्चुअली इज बैच साइज, आप उसको डिफाइन कर सकते हो, राइट? सो मीन्स people who still want to see कि क्या हो रहा है, कैसे हो रहा है, you can play with this architecture. आप इस तरह से features को add करके you could design your neural networks on the go. Fine. Very useful, innovative thing from Google itself, and it's free. आप इसको scroll कर लेना, इसको देख लेना. It will work on your browser also. And there are courses, means there are video lectures also. Again, आप ये सारा देख लो. It's a good source also. Okay, coming back to the next regularizer. The next regularizer is dropouts, right? Dropouts. What actually are dropouts? Again, the simplest of the definition is that we remove nodes with some probability. You may be surprised. ये क्या कर रहे हैं? What is the nodes? Node means we node neurons actually, right? We remove neurons for simplicity. Please. What does that mean? कि भाई while you are training, आप probability set करते हो. Say you keep a probability of 0.5, you keep a probability of 0.5, keep a probability of 0.5, so it's between 0 to 1. आपने कोई number set कर दिया, right? It means आप ये कह रहे हो कि with a probability आप इनमें से from any layer इतने percentage of neurons को छोड़ दो while you are training. Means first time हो सकता है आप इसको छोड़ दो, first epoch पे इसको छोड़ दो. Second time you are training, it may be possible that the neural network may skip this and may skip this, and you do it for all the layers, or depending upon how many layers you want the dropout to be. Right? It has been again observed कि अगर हम ऐसा करते हैं तो we are giving the neural network a fair chance of learning the general concept rather than memorizing. Right? So dropouts works. They do work. I'll show you in the course today that I'm going to share you with in a moment. So dropout work. The theory is you please fire or skip some of the neurons into your layers depending upon आप क्या करना चाहते हो, right? तो उसका architecture किस तरह से होगा? Then these connections will not work. तो ये connection जो इसको जा रहा था, so they are not gone. They are gone now. See this one. Right? And it's all random. कभी ये miss होगा, कभी ये miss होगा, so it's random. So dropout means you just skip those neurons. You set up with the probability and do it, right? It helps in actually overcoming the memorization problem for neural networks. Right? Why dropouts work? We train smaller networks, therefore it has regularization impact. We cannot rely on only one feature, so we have to spread the weights. तो अगर आप means आपने weights के combination को spread कर दिया instead of just keeping it into particular, you can say range. You have actually spread out, and when random inputs are on and off, तो देखो आपके पास layered architecture है. Say this is layer 1, then you have layer 2, then you have layer 3. Layer 2 को input मिलनी है layer 1 से, layer 3 को input मिलेगी layer 2 से. up randomly, if I'm say looking at perspective of layer 3, right? So layer 3 के perspective से उन्हें नहीं मिला जल्दी स्कोर नहीं आ रहा, मैं लेक्चर के बाद आ रहा हूँ, मैं लेक्चर के बाद आ रहा हूँ, मेरी क्लास चल रही है, थोड़ी देर में आ गया। उनको बता दो। So layer 3 पे what layer 3 is getting, it's getting from layer 2 only, right? So layer 2, अगर मैं इस inputs को कभी कुछ दे रहा हूँ, कभी कुछ दे रहा हूँ, so in a way layer 3 is learning different things every time, right? So this is the whole theory in dropouts. Fine, I hope this makes sense, right? Dropouts. Then the next one is mini batch. What is actually is mini batch? Mini batch is that we have abundance of data, right? We have say millions of samples. Say we had 1 million, 2 million samples. So when we say that we pass on the sample and then update the weights, there are different possibilities. You please assume मेरे पास से 1 million samples हैं. मैंने 1 million samples पास किए न्यूरल नेटवर्क को, राइट? फिर मैंने उसकी आउटपुट निकाली, फिर मैंने उसका एरर मेजर किया, डिपेंडिंग ऑफ दिस एरर मैंने वेट्स को अपडेट किया, आई हैड अपडेटेड द वेट्स, फाइन। तो मैंने वेट्स को अपडेट किया। सो passing on million samples and making some calculations and then updating the weights is a tedious task. Tedious task means मेरा first weight update कब होगा? My weight will be updated after 1 million samples. और 1 million samples इकट्ठे पास करना या 1 million samples के पार्शियल रिजल्ट्स को स्टोर करना, इट्स अगेन कॉम्पिटिशनली वेरी एक्सपेंसिव. So what is thought about? Thought about कि भाई क्या करें? If I go with 1 million samples, things may not work. If I go with just one sample at a time, कि मैं कहता हूँ एक first sample उठाऊँ, I pick first sample, pass it to the training process, learn the error and then update it. So I have to make updations 1 million times. So that is very slow sort of process. तो बड़ा slow process है इस तरह का. So which is bound to take time. तो वो time ज़्यादा लेगा. और इसमें मेरे जो ग्रेडियंट्स की जो वैल्यूज है वो मतलब इट कुड गो एनी अराउंड लाइक दिस, राइट? बिकॉज कभी कहाँ जाएगी, बिकॉज माई फर्स्ट सैम्पल में टेक यू इन द करेक्ट डायरेक्शन, नेक्स्ट सैम्पल में टेक यू इन द इनकरेक्ट डायरेक्शन, सो इट्स ऑल जम्बल्ड अप फॉर sizes 1 training sample. People thought about why can't we break these million samples into small batches, and this gives the name as mini batches, right? Or mini batching, right? And again it has been seen कि it performs better, right? इसके results भी अच्छे आते हैं, training भी आपका simple process, training fast होता है, so it's in a way beneficial to all, right? Beneficial for competitions, beneficial for the training process also, right? Mini batching. Size of mini batching is very critical. आप भी you play around. अगर आप batch size suppose रखते हो say 64, 128, right? They may have different results. दोनों के different results आएंगे for say batch size 64 and batch size 128. Right? Again, batch gradient descent is this one. होल बैच पूरे का पूरा बैच पास किया आपने, देन इट्स वेरी स्मूथ लाइन, क्योंकि पूरे बैच के साथ आपने रिजल्ट को निकाला, फिर आपने उसको पास कर दिया, वेट अपडेशंस किए, देन इट्स रेगुलर कर्व. मिनी बैचिंग के साथ यू मे ऑब्जर्व कर्व्स, zigzag पैटर्न, बट अगेन इट इज फास्टर, सो वी स्टिक टू दैट मिनी बैचिंग. बैच साइज का बड़ा इफेक्ट रहता है. बैच साइज अगेन पिक्ड एन इमेज फ्रॉम गूगल. बैच साइज 10 की कर्व है, बैच साइज 20 की कर्व है, 50 कर्व है, 100 की कर्व है. सी दिस वन. The curve with 100 is in the red one. Please see this. This is more of smoother curve. Right? Again, no golden rules. Play around and find out what batch size works for you. Please. I'll skip this. Right, again, in terms of learnings or improvements, कैसे हो रही हैं. Gradient descent with momentum. Momentum means you add a factor, right? Add a factor so that you end up at the minimum quickly. Just this one. It works with stochastic gradient descent, which works only with the batch size 1. Momentum. I'll show you this one. This also has been proven to be in a way very beneficial for training, right? बड़ी जल्दी training होती है इससे. what actually is the one key, instead of just oscillating, if you see this oscillations, right, this is the go. So can we add a momentum vector? Momentum vector means instead of just popping up and down, so मेरा जो effect रहेगा इस तरह से रहेगा, like this one, means I'm moving forward also, right? Again, lots of theory, right? So please compare these curves. So this is a normal, say, stochastic gradient descent, and this is with momentum. Momentum means you are shifting it to the next, to the next, to the next. Next one is batch norm. Batch norm. Again, I'll be very abstract in the sense, we have seen normalization of the inputs. Normalization of the inputs देखा हमने, and it is found to be helpful. What batch norm is, कि if we are normalizing the inputs, right, and it has proven to be beneficial, why can't we normalize all the hidden layers also? कि हम hidden layers पे भी ये concept क्यों नहीं apply कर सकते? Because at the end, if I had say bigger network, अगर मेरे पास ये बड़ा network है, it's a bigger network, मैंने यहाँ तो normalization कर दी, I had normalized this. This is normalized, right? Say again, this is very 1, 2, 3, 4 layer network. Please correlate it with a number of layers. Say मेरे पास 20 such layers का network है. So if I just pick, say this is my layer, say this is layer number 10. This is my 10th layer. 10th layer पे जब मेरे weights propagate हो रहे हैं, so यहाँ पे normalization नहीं है. So क्या problem हो सकती है? There is a chance कि मेरे जो gradients calculate हो रहे हैं, they may overshoot. Overshoot means कि उनकी जो value है बहुत ज़्यादा बड़ी हो गई है. It is quite big, right? Or they may undershoot. Undershoot means its value is almost zero. So the concept is that it will be helpful again if we could normalize even the values at these hidden layers also, right? So this particular concept is known as batch normalization. Right? It's almost same concept. Bias आप mean calculate करके उसमें से subtract करते हो, right? You minimize the variance. Variance becomes zero for the layers. But the only difference is you don't do it with respect to your inputs, right? You do it with respect to your previous layer outputs. मतलब suppose if I'm talking about 10th layer, so I may be more interested in normalizing it with respect to the 9th layer, because my 10th layer is actually having my inputs from the 9th layer, and my 9th layer is having the inputs from 8th layer, right? So in a sense कि मेरे लिए if I see the perspective of my 10th layer, say it is my 10th layer. For 10th layer, there is nothing before 10th layer. Means 10th layer को क्या दिख रहा है? 10th layer is only looking at what 9th layer is passing it to. Right? So batch norm is this one. Again, this has proven to be successful, right? It has definitely proven to be speeding up your training. ये speed up करती है training को, and it has a slight regularization effect, because now willingly or unwillingly or intentionally or unintentionally आपने क्या किया? आपने जो normalize कर दिया उसको, उसके weights को फिर एक तरह से एक range में ले आया instead of scattering it everywhere, right? It has a slight regularization effect. So the rule is that you please use batch norm for speeding up your training process rather than adding it as a regularizer. Batch norm. Fine. Okay. Queries. This we have discussed. Learning weight decay. And last one is early stop. Early stop means if I had a graph like this, right? So this is the graph. It gives me my training error and deviation error. Or if I look at this graph, I know that till this point, or maybe at this point, my training algorithm was perfect. Okay. यहाँ पे भी देखो तो यहाँ पे भी error इतना ज़्यादा बड़ा नहीं है. But gradually, if I say at this iteration, say this is 100 and this is a 50. At 50th iteration, the error may be minimum between training set and dev set error. It means यहाँ पे जो weights थे वहाँ पे मेरे पास एक अच्छा result आया for both training set error and testing set error. So what you can do, you can guide or you can tell your learning algorithm to stop. आप उसको बोल सकते हो कि भाई जल्दी stop कर दो when the error is minimum or when the validation error is minimum. आप वहाँ पे stop कर दो. Don't continue with the training, because if I do the training further, it doesn't have a positive effect, it has a negative effect in fact. तो आप इस जगह पे weights को save कर लेते हो, you save the weights here. and then use it these saved weights for your final model deployment. आप model को deploy करने के लिए फिर से उसको use करते हो rather than going to 100th iteration. Right? Okay, so this is from my side regarding the theory, sir. I am open to queries, right? Discussions. जस्ट टेलिंग यू कि इन सारी चीज़ों का जो मैंने अभी थ्योरी में डिस्कस किया इनका इफेक्ट होता है, एक्चुअल में होता है. फर्स्ट आई विल वेट फॉर सम क्वेरीज और पॉइंट्स टू बी डिस्कस्ड. Okay, if it is done, so again, I have data set, so which is a handwritten digits data set, right? इसमें handwritten digits हैं like this, right? 1, 2, 3 digits हैं. So first is आप उसको train test में लेके आओ, right? Then this is my network. So this network is pretty standard across all. पूरे notebook में यही network चलता है. Convolution layer with 200 filters, 100 filters, 60 filters, 30 filters, and last is 10. Softmax layer. Why? Because my number of classes are 10 here. ReLU activation, ReLU. This is the activation that I have. I compile the model with Adam optimizer, and the loss function is categorical cross entropy function. Right? Matrix is I'm measuring the accuracy, right, for plots. Right. This is the summary of my model. Total of 3,72,000 approximate parameters that we measure, right? Fine. So first time train किया इस network में कुछ भी नहीं है. It's a simple network, nothing. कुछ भी नहीं है, कोई regulation नहीं है, कुछ नहीं है. If you see, I have trained it for 50 epochs, right? Validation के लिए मैंने इसी को split कर दिया. Again, the libraries help you to split your training data like this. आप इस तरह से भी स्प्लिट कर सकते हो या आप एक्सप्लिसिटली अपने ट्रेनिंग वैलिडेशन डेटा को पास कर सकते हो. बट अगेन इट्स अ इम्पॉर्टेंट थिंग, यू प्लीज पास ऑन योर वैलिडेशन डेटा. तो दो तरह के रिजल्ट्स आ रहे हैं आपको, लॉस एंड एक्यूरेसी. दो फर्स्ट दो नंबर्स हैं, दे आर फॉर ट्रेनिंग लॉस एंड द लास्ट टू नंबर्स आर फॉर वैलिडेशन लॉस एंड वैलिडेशन एक्यूरेसी. एज यू
सर वैलिडेशन स्प्लिट जो आपने दिखाया है, प्लीज सर दिखाना.
यस सर.
0.1 मींस
0.1 10% सर.
10%. ओके.
अगेन आप अपने डेटा के हिसाब से इसको ब्रेकअप कर सकते हो. तो दीज आर द नंबर्स. अगेन नंबर्स आप देख लो किस तरह से हैं. मतलब अगर मैं इसको ढंग से ऑब्जर्व करूं, खाली ठीक है. इट हैज़ गिवन मी 99, इवन सिंपलर मॉडल हैज़ गिवन मी 99.8% ट्रेनिंग. वैलिडेशन लॉस इज बिग 0.37. एक्यूरेसी इज 95, विच इज अगेंस्ट यू कैन से नॉट दैट ग्रेट. सो मेरा जो नेटवर्क है एक तरह से ट्रेनिंग डेटा पे तो ठीक काम कर रहा है. वैलिडेशन डेटा पे देन आई हैव टू अप्लाई द ट्रिक्स. तो ये मैंने प्लॉट्स डिफाइन किए. हाँ, इसमें बैच मैंने 1 लिखा है. आई थिंक देयर इज नो बैच. Batch size is not 1, I think. Yeah. Fine. So batch size is 1. So these are the plots that we'll get, right? Again, there's a gap, right? Indication. But mind you कि मैंने plots 0.1 से 7 तक किए, थोड़ी सी बड़ी पिक्चर भी दिख रही है आपको, वो भी एक रीजन है. Then mini batching मैंने यूज की. Mini batching means rather than updating the weights one by one, मैंने batch size दे दिया 100. मतलब 100 की सैंपल्स उठाएगा, उसको ट्रेन करेगा, राइट? ट्रेन करने के बाद फिर वेट अपडेट करेगा एंड यू कुड सी द रिजल्ट्स. स्टार्टिंग ऑफ द उस पे ही उसने वैलिडेशन एक्यूरेसी 98 तक ले दी. नथिंग, कोई और चेंज नहीं किया मैंने पूरे मॉडल में, राइट? सो ओवर द पीरियड ऑफ टाइम एक्यूरेसी इज okay, fine. So it has given me an accuracy of this one. My validation loss is again decreased. Accuracy is 98 something again. It has fallen a bit, but it is okay. मतलब improvement दिख रही है मेरे को without any optimization. मतलब इसमें कोई optimization नहीं है, only batch size is there still. But these curves are now getting smoother, right? थोड़ी smooth होती रहेंगी over the notebook's time. Then next task मैंने क्या किया, drop outs लगाए. ड्रॉप आउट मीन्स जो वही थ्योरी की एट रैंडम आप कितने सैम्पल्स को डिस्कार्ड करना चाहते हो, राइट? इसको लगाने का तरीका क्या है? यू प्लीज इंपोर्ट दिस लेयर, ड्रॉप आउट लेयर, फ्रॉम केरास डॉट लेयर्स, राइट। फिर मॉडल डॉट ऐड ड्रॉप आउट कर दो 0.20, मीन्स मैंने 20% की रेशियो से ड्रॉप आउट्स लगाए हैं अपने, राइट। रेस्ट ऑल इज सेम, दिस इज सेम. Do we have something? See, validation loss. Observe this. First epoch पे ही validation. Rest all is same. Batch size 100. Right. I scroll through this one, next one, next one. Right. Validation loss is considerably low as compared to this one. So मेरा loss कम हो रहा है. Accuracy is again. Okay. So जब मैं प्लॉट करूंगा मेरी कर्व्स और स्मूदर आएंगी. See the curves. ये मेरे पास उसकी कर्व है accuracy की. They are a bit smoother. देखो उनकी शेप स्मूथ होगी, means oscillations are less. I was not able to, but ये कर्व प्लॉट करोगे तो ये भी स्मूथ दिखेगी आपको. तो मेरी नोटबुक एक्चुअली डिस्कनेक्ट हो गया था, इस वजह से आई लॉस्ट दिस वेरिएबल. बट इफ़ यू री रन इट यू कैन प्लॉट दिस एंड यू विल ऑब्जर्व कि जो कर्व्स हैं बड़ी आपकी स्मूथ हो गई आपकी, राइट. देन आई एडेड अ बैच नॉर्म टू दिस वन. बैच नॉर्म लगाने के लिए क्या करना है आपने, यू इम्पोर्ट बैच नॉर्म अगेन फ्रॉम केरास डॉट लेयर्स. तो मैंने क्या किया, अगेन ये बड़ी एक क्रूड फॉर्म में मैंने बैच नॉर्म्स लगाई हैं. इट्स नॉट कि आपको ऐसे बैच नॉर्म्स लगानी चाहिए. बैच नॉर्म्स आपको लेयर बाय लेयर लगानी चाहिए. इवन द ड्रॉप आउट्स भी आपको डिपेंडिंग अपॉन आपकी लेयर में कितने कनेक्शन हैं उसको ध्यान में रख के ये सारी चीज़ें लगानी चाहिए, राइट. फॉर दिस मतलब दिस इज अगेन फॉर टीचिंग परस्पेक्टिव. मैंने सभी जगह लगा दी बैच नॉर्म हेयर एंड बैच नॉर्म हेयर टू द फर्स्ट 2 हिडन लेयर्स. यहाँ पे नहीं लगाई बिकॉज नंबर ऑफ कनेक्शंस आर रिलेटिव लेस हेयर, right. So if I just observe the results, so it has again improved a bit, right. But because again improved a bit, but it's an improvement means अगर जब आप 98 99 तक पहुंच गए हो तो improvement इतनी ज़्यादा नहीं रहती. मतलब again you are struggling to reach 100%. 100% पहुंचने के लिए कोशिश कर रहे हो, but even it's perfect, almost good. Validation accuracy is this one, this loss is this one, right. Almost seems to be perfect, almost perfect. So fine. So my curves are getting closer as per my desired things. So थोड़ा सा है, but it's again, but if you look at this, मेरा ये plot देख लो कहाँ से कहाँ है. It's from 0.01 to 0.04. तो इसी वजह से आपको थोड़ा सा बड़ा दिख रहा है ग्राफ में. Just for pointing out like this, मैंने जानबूझ के ऐसा बनाया 0.2. But it's a fairly small numbers to play. Then I added regularizers. मैंने regularizers को add किया. L1 regularizer, इसका कोई ज़्यादा अच्छा impact नहीं आया. I'll just regularizer add करने का तरीका क्या है? Activity, please add activity regularizer is equal to N1 with some value of lambda. Lambda is 0.03. आप इस तरह से एक regularizer को add कर सकते हो. It doesn't have a good impact. So see the graphs like this. So it has oscillated. Can't trust. Even the accuracy is decreased. The validation accuracy has also decreased. So it's not a good sort of thing to be done for my data, right. Then I tried with L2 regularizers. So बाकी सारा graph वैसा ही है. L2 regularizer मैंने try किया. Again you can argue कि सर ये ज़्यादा अच्छे नहीं है, but वो ठीक है. मतलब it's better than L1, right. So these were the final results that you could have, right. ग्राफ्स आर अगेन सिंस एक्यूरेसी तो बड़ी अच्छी आई, ड्रॉपआउट्स भी कम हो गए, बट फाइनल वैल्यूज इतनी ज़्यादा अच्छी नहीं थी आपकी एक्यूरेसी की. देन आई एडेड द रेट डिके. अब रेट डिके करने का मतलब क्या है, आप रेट को, लर्निंग रेट को स्टेप बाय स्टेप कम कर रहे हो. तो उसके लिए क्या करना है, आप इस तरह से कोड लिख सकते हो. यू कुड सेट योर इनिशियल लर्निंग रेट. मैंने इनिशियल लर्निंग रेट सेट किया क्या है. Then I decided upon epochs, maybe 50, 100. Then I found out a variable decay. Decay is equal to initial learning rate divided by epochs. मतलब मैंने एक फैक्टर निकाल लिया, मैं कितने रेट से डिके करूँगा इसको. तो dividing by this number. Then I just wrote this simple function. Sorry. ये नहीं है, ये वाला है. Decay rate is this one. Then I added a momentum factor to this one. मैंने momentum factor इसमें ऐड कर दिया. बिकॉज मैंने लास्ट में बताया था कि मोमेंटम से क्या होगा, आपका स्पीड अप होगा. तो जब मैंने ऑप्टिमाइज़र बनाया, ऑप्टिमाइज़र को बनाने के लिए मैंने क्या किया, हैव यूज्ड एसजीडी. नाउ माय लर्निंग रेट इज एलआर, राइट. मोमेंटम इज मोमेंटम एंड डिके को मैंने डिके रेट दे दिया. डिके रेट विल बी कैलकुलेटेड फ्रॉम दिस वन. मीन्स आफ्टर एवरी स्टेप माई वेट विल बी डिकेड. मेरा वेट डिके होगा हर बार. Then I just trained it. एंड सी इफेक्ट देखने के लिए एक तो मैं फाइनल रिजल्ट्स दिखाऊंगा आपको. फाइनल रिजल्ट्स आर एज यू कुड सी लॉस इज दिस small 0.0016 loss and 99 almost perfect. But the important point to see the training time. It just took 18 seconds for single epoch. Right? I'll compare it with the other methods at the top. But 18 सेकेंड में उसने मेरी एक epoch को handle कर दिया, and it's fairly pretty good sort of results, right? Something that you could again settle for. बड़ी स्मूथ कर्व्स दोनों मीन ऑसिलेशन बिल्कुल नहीं है. इट इज परफेक्ट, ऑलमोस्ट परफेक्ट. राइट, ये वैल्यूज बड़ी क्यों दिख रही हैं? अगेन बिकॉज इट्स प्लॉटेड ऑन अ स्केल 0.0121. उस स्केल में प्लॉटेड है, इस वजह से आपको बड़ी दिख रही है. जस्ट द लास्ट पॉइंट, 18 सेकेंड्स. प्लीज ऑब्जर्व, आई विल अगेन गो फ्रॉम द टॉप. कोलैब पे मैंने ट्रेन किया इसको. मेरी फर्स्ट जो थी, इट हैज टुक 172 सेकेंड्स फॉर ट्रेनिंग. उसने 172 सेकेंड लिया, ऑलमोस्ट more than 3 minutes for one epoch. Batch size of 1, right? Batch size of 100, it took me 27 seconds for batch size of 100, right? Then is there any difference? So 34 for this one means, मतलब आप दोनों को compare करो, 172 versus 18 seconds for training of just one epoch, and that is done with the momentum factor. Fine. That's it from my